Chapter 14, Turbomachinery. All right, class, today we are going to imagine we are playing with water wheels and fans, because that's the easiest way to explain turbomachinery. Turbomachines are machines that use a spinning part to either give energy to fluids or take energy from them. Let's start with pumps. A pump is like when you use your arm to push water up from a well. In big machines, we use blades that spin to add energy to water or air, pushing it to higher places or increasing its pressure. On the other hand, turbines are like water wheels, where water turns the wheel, and we take that energy to make electricity or run machines. So pumps add energy, turbines take energy out. Sometimes we call them all pumps if they move liquids, and fans, blowers, or compressors when they move gases like air. A fan moves air gently, like your ceiling fan. A blower moves air stronger, like a leaf blower. And a compressor squeezes air to very high pressures, like in a tire pump. Some machines move fluid by squashing it inside a closed space, like your heart pumping blood. These are called positive displacement machines. Others just use spinning blades, called dynamic machines, like the fan in your laptop or a wind turbine. When we use pumps, we always think about how much water they can push in a second, called flow rate, and how much they can lift the water up, called head. The higher the head, the more powerful the pump. But nothing is perfect. Some energy is lost to friction and leaks, so we have to supply more power than what actually goes to moving the fluid. We call the useful power water horsepower, and the power we supply is brake horsepower. The efficiency is simply how much useful power we get out of what we put in. In real life, pumps have sweet spots called the best efficiency point, where they work the happiest, moving water smoothly and using the least electricity. We can see this in a simple curve, where too little or too much flow makes the pump unhappy, but in the middle it is very efficient. We also need to make sure pumps don't suck too hard and create bubbles. These bubbles can pop inside the pump and damage it, a problem called cavitation. To avoid this, we use a safety measure called net positive suction head, or NPSH, which is like making sure the water doesn't boil inside the pump. Sometimes engineers use pumps together, like two friends helping to pull a rope. When we put pumps in series, it's like stacking them to lift water higher. When we put pumps in parallel, it's like adding extra lanes to make more water flow without increasing height. Then we have positive displacement pumps, like your mom's kitchen hand mixer but for liquids. These are really good for moving thick or sticky stuff, like chocolate or syrup, because they don't need to make the fluid move fast, they just push it along. Finally, engineers use something called specific speed, which is like a guide to help them pick the right size and type of pump or turbine for the job. They also use models and small versions to test how big machines will work without building the giant machine first. So, the next time you see water coming from a tap, wind turning a turbine, or air blowing from a fan, you're watching turbomachinery quietly doing its job, making our world more comfortable and our machines work better.